you're watching this for the 4.4 video, realize that it was on last week's video, so go look at that. This is it all filled out from last week. We didn't quite get to that as a class, which is fine. We're going to deal with the rest of the videos for this week, so take a look at this video from last week if you need this information. And let's go ahead and start on 4.5, if that's okay. All right. So analyzing sequences and functions. So we have an input and output machine. So sometimes inside that machine is f at x, which we know is y. So they gave us the equation y equals 3x minus 4. We know that this is an equation. Tells us how we can get y if we know x. And being y is the same thing as f at x, that's the same idea. Okay, instead of writing y equals 3x minus 4, we can write y equals this. These mean the same thing. It's just we replaced y with f at x. F at x is indeed, it's called functional notation. All right. The parentheses show you're plugging in a number into the machine. So if we were to plug into here, so this particular problem, I'm going to be replacing the x each time. And I'm just going to show you on each of these. You see how where the x was is getting changed to whatever the number is inside the parentheses. And then you do the math with it. 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. 3 times negative 1 is negative 3 minus 4 is negative 7. 3 times 0 is 0. 0 minus 4 is negative 4. 3 times 1 is 3 minus 4 is negative 1. 3 times 2 is 6 minus 4 is 2. 3 times 3 is 9 minus 4 is 5. Pretty simple, huh? All right, so now we change it a little bit. So now they tell us that f at x is equal to 22 or f at x is equal to negative 19. That's a little bit different. I'm not replacing the x this time. I'm replacing f at x. So I'm going to go 22 is equal to 3x minus 4. And I'm going to go negative 19 equals 3x minus 4. So we're going to add 4 to both sides. And then we're divide each side by 3. And we get a fraction. So even just as a reduced fraction, 26 over 3 is reduced. You don't make it a mixed number in high school. Just leave it as that. This next problem, we're going to add 4 to both sides. Negative 19 plus 4 is negative 15. It's equal to 3x. Let's divide both sides by 3. Negative 15 over 3 is negative 5. So negative 5 is equal to x, or you can flip it over to make it x equals negative 5. So we have this particular function given the same function we've been looking at as an input, evaluate, find the output, show how you work. So f at 2, we're doing this. That gives us negative 4. Okay, this is all what we've been doing, correct? Okay, so we're going to do the same thing. We're going to replace the x with the number inside. So that's going to give me positive 20, because negative times negative is positive, minus 1, so I get 19. This is going to give me positive 6, because negative 2 times negative 3. Subtract 1, so I get 5 for an answer. This is going to give me 0. 0 minus 1 is negative 1. This is negative 10 minus 1 equals negative 11. Okay, this next one, again, we're going back to it. This is the one where we're replacing this entire thing with the number that's given. So I'm going to go 21 is equal to negative 2x minus 1. And on this one, I'm going to go negative 7 equals negative 2x minus 1. We're going to add 1 to both sides. That gives me 22 over here. Divide both sides by negative 2, so I get negative 11 equals x, or you can flip it over, making it x equals negative 11. add 1 to both sides, divide both sides by -2. Negative over negative is positive, and you can flip this over to look like that. Okay, this is going to be the homework you want. This video will continue. If you just copy down what we did, that means you have no idea how to do the problem. Okay, so don't just copy it down. Use this as a guide. All right, so notice we have f at x, we have g at x, we have h at x. They mean the same thing. It's just y equals y equals y equals. But what I'm going to do is I'm going to highlight this one. That's going to go along with these. I'm going to highlight this one, g at x, is this one, and we're going to use g at x down here too. Then we had h at x, which is this one. And then we'll use h at x down here. Looks like we didn't do a f at x equals a number there. That's okay. All right, so let's go ahead and solve these. So remember, I'm replacing the x. I'll go right down this list. 1/2 times -2 plus 7, 1/2 times 0 plus 7, and 1/2 times -6 plus 7. So half of 10 is 5, 5 plus 7 is 12. Half of 2 is 1, half of -2 is -1, so -1 plus 7 is 6. Half of 0 is 0, 0 plus 7 is 7. Half of 6 is 3, half of -6 is -3, so -3 plus 7 is 4. Okay, now we're going to do the same thing with the g's. So look at our above problem. So I'm going to go -7 plus 4, -4 plus 4, -9 plus 4, and we'll just start with those. So that's going to give me -7 plus 4. Add those together to get that. Negative times negative is positive. 4 plus 4 then is 8. Negative is positive, so 9 plus 4 is 13. We'll come back and solve these two at the end. All right, again, we're going to plug 0 in for where we had x on our yellow equation. So 5 times 0 is 0. 0 minus 2 is -2. 5 times -9 is -45. -45 minus 7 is -47. Or -45 minus 2 is -47. 5 times -9 is -45. -45 minus 2 is negative. Oh, wait. I plugged the wrong number in, didn't I? That should have been a 4. I'm so sorry. 5 times 4 is 20. 20 minus 2 is 18. The last two problems, remember, we're going to set it equal to, so I'll use my blue equation. So 20 is equal to -x plus 4, and then also 8 equals 5x minus 2. So we're going to subtract 4 from both sides. That's going to give me 16 equals -x. Multiply both sides by a negative. You can flip it over as well. This one we're going to add 2 to both sides. Divide both sides by 2, and flip it over. Oh, I guess we did have that, so we're going to be able to take that. We're going to go 17 is equal to 1/2 x plus 7. G at x is going to be -7 equals -x plus 4. H at x is going to be -17 is equal to 5x minus 2. So we just went the appropriate. All right, so if I go ahead and add 17 to both sides, that gives me 24 equals 1/2 x. Multiply both sides by 2, and those cancel. So I get 48 is equal to x. You can flip that over to give you x equals 48. Subtract 4 from both sides. Multiply both sides by -1. X equals +11. Add 2 to both sides. Divide each side by 5. And we're all done. All right, so now I have a little bit of a word problem that goes with it. It says a function c at b is equal to 8x plus 10 models the cost that James's family pays for burgers at their local burger shack, including the $10 tip they give the waiter. So if we want c at 3, I'm going to plug 3 in for my x. That's where x was, so I'll be a 3. Okay, so this is 24 plus 10. That gives me 34. So $34 is, when they did it, explain what the answer means. 3 burgers plus tip equals $34. Evaluate C at 7. So I'm going to plug 7 in. So that's 56 plus 10, which is 66. Okay, that means they bought 7 burgers and that cost $66. This one, ooh, we have 82. I guess that's the cost of our bill. So we're going to go 8x plus 10. Subtract 10 from both sides, so that's going to give me 72 is equal to 8x. Divide both sides by 8, so x is equal to 9. So 9 burgers bought. Explain what that means. So we did. Explain. 9 burgers were bought, and it cost us $82, and that included the $10 tip. Okay, so for this is 4.6 is the next day lesson, so just pay attention to what you're doing in class if you're watching this during class. If you're not doing 4.6, then go back in the video and find what you're doing in class. A blank is a set of ordered pairs. A blank is a type of relation in which x has at most blank y value. The blank of a relation describes all x values. I know this is domain. The blank of a relation is all the y values, which is range. A function, I guess we can say a function is a set of ordered pairs. A function is a type of relation. A function is a type of relation. That means you have only one y value. So we'll talk about that as we get down here a little bit more. So a function is basically all the graphs you've dealt with. Sometimes a function or function can't have any extra y value. So when you look at this, we have 2 goes to 4, 4 goes to 8, 10 goes to 20. This is a function. Let's do the same thing here. 1 goes to 20, 1 goes to 8, 4 goes to 4. Do any of these y's repeat? No. But look at this. 1 goes to 10, 2 goes to 10, 3 goes to 10, 4 goes to 10, 5 goes to 10. Is this a function? No. And then 1 goes to 2, 2 goes to 2, 3. Oh, wait, these repeat, so this is not a function. But you can still create the domain. The domain's pretty simple. It's just 2, 4, and 10. And sometimes we put that in these weird brackets. The range are the y values, so 4, 8, and 20. They should be in order. If they're not in order, it's not the worst thing in the world. The domain of this, I don't have to list the 1 twice. If you wanted to list it twice, you're okay, but no worries if you don't. And then the range is 4, 8, and 20. The domain of this one is 1, 2, 3, 4, 5. It's all the x values. The range is just 10, and that is not a function, so that's okay. Domain of this one is 1, 2, and 3. I don't have to list the last one. That's okay. The range is going to be 2, 0, and 5. And again, we don't have to list the 0 twice. Is this a function? Well, 3, 1, and 5. They don't repeat. It is a function. Explain. Y value does not repeat. Repeat? Nope. Domain is going to be the x values, so 2, -4, and 0. Okay, you can put them in order, but you don't have to. The range is 3, 1, and 5. Is this a function? I have -2, -5, and 1, so yes, the y values don't repeat. Y value, no repeat. The domain of it is going to be -4, 2. I don't have to list the second 2. If you do, it's not wrong. The range is going to be -2, -5, and 1. Okay, is this a function? 3, -2, and 3. No. Y repeats. That's why it's not a function. The domain of it is going to be 1 and -3. The range of this is going to be 3 and -2. And again, you don't really have to worry about putting them in order or anything like that. You're fine. The vertical line can be performed to determine if a graph is a function. In this case, if a vertical line crosses through any point of the given relation, it is a function. Okay, so if I drew a whole bunch of vertical lines here, let's just pretend I can draw straight up and down. It only touches, the vertical line only goes through one, so this is a function. This one isn't. Okay, we could show a whole bunch of vertical lines that keep crossing. So that's not a function. Circle, not a function either. Vertical line crosses it too many times. Just this letter V looking thing, vertical line, yeah, function works. Number 16, we're going to replace our x values with each of these. So that's going to give me negative 6 plus 3, which is negative 3. That's going to give me negative 4 plus 3, which is negative 1. This is 2 times negative 1. That's negative 2 times 3, or plus 3 is 1. This is 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. Okay, remember we're going to replace f of x on this one. So I'm going to go 13 equals 2x plus 3. And on this one, I'm going to go negative 7 equals 2x plus 3. Subtract 3 from both sides. That's 10 equals 2x. Divide both sides by 2, so x is equal to 5. Go ahead and subtract 3 from both sides. I get negative 10. Divide both sides by 2, so x equals negative 5. All right, we're going to work along with this worksheet, but again, if you just copy this down, you have no idea what you're doing. You're just cheating. Okay, and it shows on the test that you don't know what you're doing because you didn't practice. So use this as a guide. Don't use it as a cheat sheet. All right, do my y values repeat? No, they don't. So yes is a function. The reason y doesn't repeat. This one, 4, 2, negative 3, 8. Yes, this is a function. The y's don't repeat. This one is not a function because I have a repeat of the y. This one, 6, negative 2, negative 3, and 5 is a function because the y doesn't repeat. Is this a function? 5, negative 5, 5, negative 5. No, the y repeats. What about this one? Negative 1, 3, negative 2. Yes, it's a function. The y doesn't repeat. 2, 4, and 6 is also a function because it doesn't repeat. Vertical line test. This is not a function. The vertical line hits the graph 2 times. Okay, is this a function? Yes. Vertical lines don't cross it more than once. Vertical line on a circle, that is no. Vertical line on a straight line going that way, yes, that's a function. Vertical line this way, these are called hyperbolas, that they don't work. Vertical line of a parabola, yes, it's a function. Okay, you can, this is easy, create something that is a function. 1, 2, 3, 4, 5, 6, 7, 8. That's a function. 1, 2, 3, 4. 1, 1, 1, 1. That's not a function. These are just examples. There's infinite numbers that aren't. All right, we're going to take negative 4, plug it in. So I'm going to get negative 4 plus 2, negative 2 plus 2, negative 2 plus 2, negative 4 plus 2, negative 0 plus 2, and we're going to solve it. 13 equals negative x plus 2. So that's 16 plus 2, which is 18. That is negative 2 plus 2, which is 0. That is negative, negative, that's positive, so 2 plus 2 is 4. Negative 4 plus 2 is negative 2. Negative times 0 is just 0. 0 plus 2 is 2. And then solve this, subtract 2 from both sides. So I get 11 equals negative x. Flip it over, multiply both sides by a negative. X equals negative 11. Okay, if we're going to go ahead and do these, I'm going to go 1/2 times negative 4 minus 5. 1/4 times 2 minus 5. 1/4 times negative 2 plus minus 5. Those should have been 1/2, so I'm sorry. 1/2 times 4 minus 5. 1/2 times 0 minus 5. And then 1/2 x minus 5 is equal to 3. So solve that. So half of 4 is 2. Half of negative 4 is negative 2. Negative 4 minus 5 is negative 7. Half of 2 is 1. 1 minus 5 is negative 4. Half of negative 2 is negative 1. Negative 1 minus 5 is negative 6. What's half of 4? That's 2. 2 minus 5 is negative 3. Half of 0 is 0. 0 minus 5 is just negative 5. And then add 5 to both sides. Multiply both sides by 2. It's all done. Okay, and you guys should be able to figure this out. Okay, talk to your teacher if you need extra help. Now, what else do we have here? We're just taking a look at this. These are some worksheets that we can go along with. Oh, cool. We're going to be done with the worksheet by the end of this video. Or done with the chapter, by the way. All right, the blank variable is graphed on the x-axis, so the input. The output is the variable plotted on the y-axis. The blank of a value of a function is the largest y value, so the max. The min is the smallest y value. A function is blank if a pencil moves up from left to right. So it moves up, it's positive. A function is negative if you go down as you go left to right. A function is blank if it's horizontal. It's 0. Okay, we'll talk about that. Make sure you ask your teacher about that. All right, so what's the domain? So I'm going to count. This point right here is the point negative 5, 2. This point here is 5, negative 2. So our domain is negative 5 to 5. It's the farthest x to the farthest right. What's the range? You're going to need to figure out your highest point here. So that's 0, 3. This point here is 1, 2, 3. 1, 2, 3. So our range from bottom to top is negative 3 to 3. What is the max value? The max value is that y value there. What's the minimum value? That's the y value there. On what interval is it increasing? Okay, so this is negative 3, 0. This is, I think we have all the rest of the points. All right, so it's increasing here and here. So use the x values to explain that. So from negative 3 to 0, and it's also increasing from 3 to 5. Where is it decreasing? It's decreasing here and here. So from negative 5 to negative 3, decreasing. It's also decreasing from 0 to 3. What is the domain of this? Well, let's figure out some points. So I got 1, 2, negative 3, 1, 2, negative 3, negative 3, negative 3. This value is 4, 4. The domain is negative 3 to 4. Okay, so then we want to find the range. So we want to find we already have our top value, but we want to get that one. So that's 1, 2, and 1, 2, 3, negative 4. So 2, negative 4. So our range is bottom to top, so negative 4 to 4. What is the maximum value? It's that value right there, which is 4. What's our minimum value? Which is that value, which is negative 4. On what interval is it increasing? It's increasing here, so I know that this is the point negative 2, negative 1. So it's increasing from negative 3 to negative 2. It's also increasing here. That's from 2 to 4. Where is it decreasing? It's decreasing right here, so that value there is 1, negative 1. So it's decreasing from 1 to 2. And where's it constant? Oh, that means it's a horizontal line, so it's flat like that. So from negative 2 to 1. All right, state the independent and dependent variables. The independent is time. Dependent is beats per minute. Beats per minute. What is the domain? Well, it starts at 0. It goes all the way to 60. What is the domain? So it goes from 0 to 60. So what does this mean in context? We're doing 60 minutes. What is the range? Well, this is my lowest, so that looks like 70 right there maybe. And this highest value here is 160. So from 70 to 160 is our range. What does this mean? Beats per minute. Okay, what is the maximum value? What does that mean? So 50, 160. So our max value is 160. What does it mean? At 50 minutes, you're at 160 beats per minute. What is the minimum? So you're looking for that right there. So that minimum is 70. So at 0 seconds, started at 70 beats per minute. Where is it increasing? Well, it's increasing here and here and here. So from 0 to 15, from 20 to 30, from 35 to 55. And where is it decreasing? It's decreasing right there and right there. So from 15 to 20, and from 30 to 35. All right, so again, we're going to do this worksheet, but again, please don't just copy it down. We need to put the points that we know, so that's negative 5, 2. That one is 4, 2. And then maybe we'll get down this one, that's 0, 2, 3, 4. 0, negative 4. You get that point right there, which is 1, 0. And let's see, domain, it goes from negative 5 to 4. What's the range? Negative 4 all the way to 2, or that's 3. So negative 4 to 3. What's the maximum value? 3. What's the minimum value? Negative 4. What interval are we increasing? Well, it's increasing here, right? So from 0 to 4, it's increasing. What is it decreasing? It's decreasing right here. So that is negative 3, 2. So from negative 3 to 0. Where is it constant? It's just constant right there. So from negative 5 to 3, negative 3. On what interval was the function decreasing? That's the same question as 6, so I don't think we have to worry about that. I don't know why we asked that twice, but it happens. All right, remember these. We're going to go ahead and plug in. This one we're going to go 22 equals. So that's 6 plus 4, which is 10. That's 4 plus 4, which is 8. That's 0 plus 4, which is 4. Negative 3 plus 4, which is 1. Subtract 4 from both sides. Divide both sides by negative 3. You can flip it over. There you go. All right, number 14. We're going to plug in to the x. And then 4 equals x over 3 minus 4. All right, so that's going to give me negative 2 plus 4, which is 2. That's going to give me negative 2 minus 4, which is negative 6. 0 minus 4 is negative 4. 1 minus 1 is 0, because 3 over 3 is 0. On this one, we can add 4 to both sides, and then multiply by 3. 24, x is equal to 24. Cool. Independent is time. Dependent is depth. Okay, what is the domain? From 0 to 12. So this is 12 hours our event takes place. What is the range? It goes to 0 all the way up to 24. What does this mean? Max depth 24. And minimum is 0, I guess. What is the maximum value? When does that occur? Max is at 24, and it occurs 24 inches and happens at 0 minutes or 0 hours. What is the minimum? What does it mean? The minimum is 0, and it happens 0 inches at 12 hours. On what interval is it decreasing? So it's decreasing here and here to here. So from 0 to, what is that x value? 6. And then from 8 to 12. Oh, wait, that was decreasing. That was decreasing, sorry. It's only increasing right there. So from 6 to 8. Didn't mean to make that mistake. Sorry about that, my friends. And we have done with the chapter, so we will be having a test on this. Make sure you know how to do it. Talk to your teacher if you have any questions. Be sure that if you're watching this in class, you know what we're doing in class, and then you can utilize this. Have a great day.